Here's a lesson on substitution where you have one equation in slope-intercept form and the other in standard form. Hopefully you know at this point that wherever you have a y equals something, right, you're allowed to take that and replace it wherever there's a y. So my first step when I rewrite this equation in the bottom is I drop down the 4x, I drop down the minus 2, and then I leave some room for my substitution to occur. So I've got these two parentheses here, and I'm going to take this 3x minus 8, it goes into the y, therefore I'm just going to write it right in here. I'm going to drop down my 4x, I'm going to distribute my negative 2. I'm going to drop down my equals, I'm going to drop down my 6. I'm going to fix that 6, that bothers me. Not much better. Try it one more time. There we go. Now I'm going to combine like terms. I have 4x minus 6x, which gives me negative 2x, plus 16 equals 6. And now I have a two-step equation. I'm going to subtract 16 from both sides. Negative 2x equals 6 minus 16 is negative 10. Divide by negative 2, and x equals 5. Now, I think x is 5. I could have made a mistake, but I want to be sure. Okay, I also need to know what the y value is. That's part of a system as you're finding a point of intersection. So if I take this equation and I say y is equal to 3 times, I think my x is 5. So I'm going to put 5 in there. And I'm going to solve for y. This is 15 minus 8, or 7. So I think y is equal to 7. Now, if you're confident, you might just go ahead and say that's your answer. But I think that's a wasted opportunity because we know that if we plug that into the other equation, 5 in for x, 7 in for y. Again, I'm getting this setup right here from this equation, and instead of the x, I have this first set of parentheses, and the second parentheses is for the y. I'm going to take my x value, put it in for x, and the y value, put it in for y. So it's 4 times 5 minus 2 times 7 equals 6. I know this is 20. That's 14. I end up with 6 equals 6, and I know that is true. So I got the 0.57 using the first equation, and I confirmed that it made the second equation true, which confirms that this is the solution. Now, there are other types of problems that you can use substitution for, although they may not be the best choice. And I'm not sure how this one's going to work out, but I'm just going to show you that you can use substitution even if you have equations where there's no variable isolated. So these are both in standard form. So what I would do in this case is I would look at this first equation, and I would isolate the x. So in order to do that, I'm going to rewrite it. So it's x plus 3y equals 5. If I want x alone, I'm going to get rid of the 3y by subtracting it from both sides. X equals 5 minus 3y, and now I have an expression for x in terms of y. Now, very similarly from here, if I took this expression and replaced it in the opposite equation, I used this equation to get here, so if I plug this in here, it's not going to go well. It has to go into the other equation. So like the other problem, I'm going to rewrite this, 6 parentheses, plus 4y equals 10. The 5 minus 3y is going to go in those parentheses. And then I have an equation with one variable. Distribute the 6. 30 minus 18y plus 4y equals 10. Combine like terms. 30 minus 14y equals 10. Subtract 30. I get negative 14y equals negative 20. If I divide by negative 14, I have y equals, two negatives make a positive, 20/14 can be reduced by 2 to 10/7, and that is what I think my y value is. Now that's not the nicest looking number, right? I'm sure you don't like fractions as much as I do. So now I'm going to take that number and I'm going to plug it in to the one of the two original equations. I'm going to plug it into the first one. That x plus 3 times that number equals 5. Now I have an equation with x in it only. So I'm going to multiply. 3 times 10/7 is 30/7. 5 is equal to 35/7. So I'm just going to rewrite that as 35/7. And then I'm allowed to just subtract 37 from both sides and get x equals 5/7. Last step is to confirm that this is correct. And on this problem, it's a lot more work because of the fractions, but if I take both of those numbers and plug them into this second equation, if I get a true statement, I know that I've done it correctly. So I'm going to use 5/7 here, and I'm going to use 10/7 here. That comes from this one. And I'm going to do some multiplication. So that's 30/7 plus 40/7, and hopefully this works out really nicely. 70/7, which is 10, equals 10. That is true, and I know that my answer is x, comma y. So the x value was the 5/7, and the y value was the 10/7.